I just took off the king valve, the micron gauge. I fix. First thing that you do once you're done recovering, and if anybody has any questions on recovery, hang around and we'll go through it. Same thing with evacuation. It's been recovered, it's been... Here is our liquid line going up into our metering device, and then he sprays into the evaporator, okay? So high side, low side is down inside. Get familiar with looking at the system. You want to take that off there because we are going to turn it on. Power is not, should happen because there's no pressure in the system. So the low side cutoff switch will not allow it to run because if we run this guy, it can overheat and burn out. No refrigerant in there to cool. I've connected my service port, my service hose to my liquid line. I have a quick charge adapter on there, right? First thing I want to do is make sure this guy is open, just in case. I purged. You saw refrigerant come out. Liquid went through here. Now any potential air that was in here is now gone. It's all filled with liquid refrigerant. Now, we are going to charge this guy. First thing we're going to do is look around and find the thermometer. There we are. It's 70 degrees in here. Beautiful. It is our goal to keep this at a very comfortable temperature in here, because otherwise I'll get very irritated. Okay, this is a clamp type thermistor. It's for measuring temperature. Here we have an analog thermometer. You can use that too. They're kind of inaccurate here. But notice, he is up against the suction line just after it comes back from the evaporator. He is insulated, so ambient air is not affecting his temperature. We want the temperature of the refrigerant in the line, not air affecting it. Second thing that you can use is a clamp type thermistor. Clamp him on. There's a small electronic device. It's actually a resistor. That's a resistance chip. Okay? K-type connector. Black side goes up. Plug him in. This is what's called a K-type connector. If anybody's interested, you can turn your meter on to a volt or to a temperature scale. You can turn it on to 400 degrees. We're reading right now 68 degrees, 68.4. When you're connected to the system, we're cracked. This guy's automatic. Allow refrigerant in. Switches, we go below the set point. Watch your gauge. You see how he's going down, down, down. He starts going up. It is pulling refrigerant in the suction line direct. I'm going to add a little more. Notice how it's shot up? Yeah. The compressor, we are. I'll feed a little more in. I'm watching my high side. The green scale is the temperature. The outside scale on both is the pressure. We are R22, so we pay attention to the green scale on here for temperature. Outside pressure, inside temp gauge set will work for 404A, R410, and R22. It will also work for virtually any other. What am I looking for on my high side as I'm charging this?
Ambient temperature, 30 to 35.
Ambient plus 30 to 35 degrees. Yeah, 100, 105. I like to stop early. I am at a little over 80 degrees. Everybody see that?
Yeah. Over 80 degrees or 180 degrees? Right now he's at 80.
The more you get this guy charged, especially with our 410.
So you want the system to equalize the...
When? High and low?
Yeah.
When? Good question. When does it equalize? And equalizing means the same,
yeah.
right?
Yeah.
When would it equalize?
When it's off.
When it's off. When I turn this off, and we will do that, you're going to see the high side bleed into the low, so he'll come down, he'll come up, and eventually they will be identical. Remember I told you when you connect your gauges and the system is turned off and you first connect, what should you have high and low? Same. Your gauges may not indicate, because he's more accurate than he is, but it'll be close. If you wrote down 100 and on this one you wrote 78 or 82 or 92, good enough. The gauges are not that accurate. Okay?
What about digital?
It's my temperature on my evaporator.
So like negative 50?
You think that's right? Well, no, let me think. Let me restate that. It is what it is. Do you think I'm undercharged or overcharged right now? Undercharged. Yeah. Number one, I'm still not near 100 here. Yeah. So let's keep adding. This is, pretend it's an air conditioning system. That's way too cold. Yeah. So let's add a little more refrigerant. At the same time, you can start watching, see how the temperature changes when I throw refrigerant in, and it starts changing and warming up. It's starting to go through the system. Let's keep adding some refrigerant. You hear the difference in that compressor when I feed refrigerant in? He starts working harder. You see how he's dropping? He's going up. But every time I do it, he inches up and goes down, inches up and goes down. I'll be honest, these gauges, they ordered all new ones. They really sucked, and I don't like. Is what in my evaporator? What is my evaporator temperature? What is my condenser temperature?
5 going down to 5. You got 90.
Right, and he's dropping. Why is he dropping? Well, but it was higher. It's now 0 or less. Why?
Is he undercharged?
Well, no, forget about under or overcharge. Watch. You got it. I added it. It went in. It shot up. Watch it go down.
It's backing
down.
up on the capillary too?
It's starting to fill the liquid line with liquid. The high side is starting to go up. Right?
Yeah.
Feed in a little more, stop. Notice how I'm doing it. I'm not just, no, we're not.
You put it out through the high side?
No, we're not. All right. I just want to get close to the point, and then I'll show you. Because we're still way low. If this was an air conditioning system, we are definitely below freezing. Right? Right?
Yeah.
What's our temperature? Evaporator?
11, 15.
Correct. What's our condenser temperature?
95.
What?
95.
95.
Yeah.
Right. We're getting close. And again, do me a favor, pop that door open down there a little bit. Put a heat load on.
Okay. Pretty cold. So just open the door a bit. Yeah. Pretty open, I guess. Right?
It should be about 10 degrees, not in the box, but the evaporator.
Yeah.
The temperature in the box is going to be about 15 degrees above. Let's feed a little more in. Notice how it doesn't drop as much or as fast as before. We're starting to saturate. We're filling the system. Feed in a little bit more. It's getting hot. Why is it getting hot?
So is this working hard?
It's doing work. You got it. It's compressing more and more. And that's removing heat from that motor. So now we're probably 20, 22. We're almost at 100 on our condenser to superheat. These guys will turn off on you. Not a big deal.
So you're just opening and closing this quick to get that
to
up?
add more refrigerant.
Okay.
And I don't want to leave it open. You got to take measurements.
That's gonna be here.
Right.
Okay.
Exactly. Now I'm in that ballpark. Mm-hmm. Time to switch over to superheat.
Okay.
Superheat is, and it's on the bottom, suction line temperature, 46 minus gauge temperature, the blue one, evaporator. If I ask you for condenser, you're going to point here. If I ask you for evaporator, you're going to point here. High, low, condenser, evaporator. All right? So my temperature here is about 24, give or take 24. My superheat is 24 minus 47.
So you got 22.
22, 23, ballpark. Our superheat is still a bit high, and it will. So we are going up ever so slightly, but this will change because don't forget that refrigerant is now taking longer and longer. All these lines need to come up or go down the temperature, and it takes time. This is what takes so long. Now, when you record your final superheat on your paperwork, don't sit there and try really to get 15 exactly. You'll be here for 3 days. And even then, you won't get it, okay? So just know how to do it. Work through it. Make sure that you ask the instructor, am I doing this the right way? Did I fill this in? Is this correct? If you have questions, ask, okay?
So, right.
Okay. That's it. Now, let's pretend I overshot. I left this guy open forever. Al was talking to me and distracting me. I thought, crap, I overcharged. What am I going to do?
You know, the high side, the way into the...
No, there's something else I got to do first. I got to go down here, and you got it. I'm going to take this guy. I'm going to close this. Otherwise, when I take this off, refrigerant's going to come spraying out. Take him off. You get a little... There.
That's pretty cool.
Put the cap back on. If you're really diligent,
Just in case you overcharge the system.
But we're not doing that. That's not part of the lab, right?
oh, but you will end up doing it. No,
Okay.
it's not part of the lab. If
Okay.
you're good, you won't overcharge,
Okay.
but you will.
Okay.
Just in case you overcharge it. Then
Right. I'm just showing you. Okay, I connect up.
So overcharge it is more than 20 of the temperature over here.
no, when you superheat
No.
lower.
Oh yeah.
Don't forget, they're opposite. Just kind of think it a few times, and then you'll get it.
Okay.
It's kind of odd, but you'll get it. Just
Maybe you can open your high side, or you gotta blade in.
you got it. I'm going to leave him closed. He's open now. I can purge. Okay, I purged.
Yeah.
All right? Point it away from anybody when you do that. Now, the system is under higher pressure than the tank. I opened it up. I removed a whole bunch of refrigerant. My pressure should start dropping, and my temperature eventually should start dropping here. You could recalculate your superheat. Suction line temperature minus evaporator gauge. Suction line temperature, evaporator gauge. Right? Suction line temperature.
If we get this at
gauge.
20, it's okay.
I don't know.
Yes.
Oh, you mean superheat?
Yeah.
Yeah, because you pointed here. 20, I don't know.
Oh, okay. Sorry.
It's,
That means-
you know, forget it. This is only used to calculate superheat. Whatever the system says you should be at is what you do. Okay? And that's it. Let me get a red pen.